So we're going to talk in 4.7. It's just a follow-up of what we've been doing in 4.4 as far as finding, our different trig functions given a unit circle. But in 4.7, we're actually looking at inverse, which is an angle. Now, there's nothing wrong with taking the inverse sine like we would on our normal calculator and pulling an angle off of that, because you can see that we have the same notation we would be to find our angle measurement here. But the problem is, come Friday on our quiz, there is no calculator that we can use. So what we're going to be doing today is we're going to be finding that angle measurement, excuse me, finding that angle measurement without a calculator. And how do we do that? Okay, so let's just take a trip back a little bit in time to one of your favorite things to do when we were looking at parent functions. I know, all those 12 parent functions that we had. And the problem comes that with an inverse function, so first of all, let's just do a little definition. An inverse function is a function. An inverse, let me rephrase that. An inverse of a function is a function if passes both horizontal line test and vertical line test. Okay, so that's a definition of a function. A function has to pass, remember that check to see if something's a function, it has to pass the vertical line test? Well, we know that if we have a parent function, that looking at that parent function, that if that parent function itself can pass both the vertical and the horizontal, then its inverse is also a function. Okay, so that's just the definition of how to determine if a parent function and its inverse both are functions. Here's our problem. All 6 basic trig functions fail the horizontal line test. All 6 fail the horizontal line test. Therefore, this is a little shorthand for therefore, is the 3 dots is a triangle. Therefore, we need to restrict domain to study inverses. Okay, we need to restrict our domain in order to study the inverses of the 6 trig functions. Now in here, we're only going to be doing sine, cosine, tangent, okay? So it's that restricting and it's that reshaping of our functions, so to speak, that can cause some confusion. And that's our problem right there, okay? Now again, another little definition of an inverse. To find inverse of a function, you flip-flop, that's a really high definition, high mathematical term, flip-flop our x's and y's. So for instance, if sine of y equals x, then I know the inverse will be inverse sine of x is going to equal y, okay? We just flip-flop the placement of our x's and y's for the inverses. Okay, so here's what's going to happen, is that if you were in an Algebra 2 class last year that did a spaghetti activity, and you had a unit circle, and I had it right here, that had a string around it. This was your unit circle, and then there was a string that you placed around this unit circle, and then you marked off on the string all the angle measurements. You guys remember that last year? Okay. Here's the critical piece of that, is that when you took the end of the string and you unfolded it out onto your paper, you got something that looked like this. Okay? So what you did is you converted from a unit circle into an x and y coordinate. all right? And so keeping that in mind from where this comes from, okay? From where this is coming from a little bit. So we're kind of going back and forth from that xy from a unit circle as well. So our basic sine function, okay, our basic sine function goes up to 1 and down to -1. True? And we have a negative pi over 2, and on our line that you did last year, some of you might have done it in radians, others of you might have done it in degrees, but our horizontal is in degrees, okay? So this is our basic parent function, what you guys would have done yesterday. That would be last year, okay? Seems like yesterday sometimes. Last year. So this is our basic parent sine function. So what we've done is we've dissected that sine function into just a smidge of it, just a piece. You've just taken a piece of it out. We took a piece out from negative pi over 2 to pi over 2, okay? So negative 90 to 90 basically is where that's at. Now, to go from your parent function, which this is, all you're basically doing here is I'm just turning my paper a 1/4 degree, and you're going to get your inverse. Okay, so here's this, and I turn it a 1/4 degree, and now I have my inverse function. That's all that happened, okay? So now my pi over 2 is my y-axis, whereas before it was my x, and my x-axis became my y-axis, vice versa. Okay, so that's going from parent to inverse. So now what we're saying is that when we're looking at, and we remember our whole goal is we want to find an angle. We're looking at inverses, so I want to find an angle of sine of theta. Okay, so how do I actually do that? And if you look at this, if I would put this so that we can understand it like on a unit circle, I have pi over 2 at the top, and I have negative pi over 2 at the denominator at the bottom. Now, if you look at your unit circle, you don't have negative pi over 2, you have 3 pi over 2. Now, that's where the problem comes, is that when we're looking to find the inverse of sine, we can only go into the quadrants that contain pi over 2 to negative pi over 2. So these are the only quadrants that I can play in. This is my playground right here. I cannot enter into this restricted area in the second and third quadrants because of my shifted domain. So I can only go from pi over 2 to negative pi over 2. Not 3 pi over 2, but we call it negative pi over 2. So for instance, and this is the part that I was talking about earlier, that this would be confusing. But here comes the part that I'm going to say, I think once we get the hang of it, you're going to see, okay, that's really not that bad. All right, so for instance, I want to find the angle of sine of 1 over square root of 2. Okay, so now grab your unit circle. Find sine. Now, one thing you're going to have really be clear on in this section is what is an angle and what's just sine or cosine? What's a coordinate point? So an angle measurement, you guys, if you're looking for an angle and it says inverse with the -1 as the exponent, if it says that, you're looking for either pi, something in radians, or in something in degrees. That's an angle measurement. But if I have 1/2, 1 over square root of 2, square root of 3, anything like that, or just 1, then that's just my sine or my cosine function. That's my ratio. Because it can get confusing because we're going to be going back and forth and back and forth. So make sure that you know what's an angle measurement versus what is just a sine, cosine trig function ratio, okay? So here, this is the ratio. X is in the spot of my angle measurement. So that means I'm looking for an angle measurement here. So I'm looking for inverse sine of 1 over square root of 2. And that's going to give me my angle measurement of X. So this is where you pull out your unit circle. Where is sine 1 over square root of 2? How much? 45 degrees. So X equals 45 degrees. What's that in radians? Pi over 4. And I'm going to want to see both. Okay? That's part of it right there. Okay, that's half of it right there. Pretty simple. But here comes the tricky part that we're going to make not so tricky. If we want to find the sine of X of negative 1 over square root of 2. Okay, this is it right here. Go back to your unit circle and find and locate there should be 2 different times that the sine is negative 1 over square root of 2. And where is that? I can't even find my unit circle. Okay, where is sine negative 1 over square root of 2? Here it is at 3 pi over 4, or 135. Nope, I lied. Down here at 5 pi over 4, or 225, or 315 and 7 pi over 4. Why can't I not do 225, 5 pi over 4? Because it's in my restricted area. It's not my playground. I can't do this. Okay, now stay with me, guys. Is this whole unit circle on here? Okay, now stay with me. For sine, I can only be in the first and the fourth quadrant. Now, if I want, here's negative 1 over square root of 2 for sine. Everybody see that, where we found that, okay? If I want to get to 315 degrees, I would take this and I would have to rotate my angle all the way around, and then I'm in the red area. I mean, alarms are going off, and, you know, the trig police are coming after you. You can't do that. Well, wait a minute. Okay, now what? Go clockwise. Now, if I go clockwise, though, what kind of angle do I have? A negative angle. So what you'll do, okay, so here's my negative 1 over square root of 2. And I know that it can't be 315 because to get to 315, I had to travel all the way around. I'm going to take the shortcut, and I'm just going to go from here down to here. Boop. So what's the coordinating angle to 315 that I would find in the first quadrant? 45. So 45 and pi over 4 become what I'm looking for here. So inverse sine of negative 1 over square root of 2 is going to give me X. So X is going to be my negative 45 degrees and my negative pi over 4. Because I cannot be in the second and third quadrants. I can only be in the first and the fourth.
So would we show like 4 answers with all of these then? Or?
Nope, just the 2.
Just,
what would the other 2 answers that you were thinking of?
Oh, I meant like negative pi over 4 and then X, or and then 45, and then do the, I guess just, would you put the degree and then radians, and then the degree in radians and negative?
No, just, this is the only answer right here, is in the negative.
Okay.
Yeah, you cannot have that 315 or 7 pi over 4. Because then that tells you you've gone into the second and third quadrants, and we can't have that. So basically now, what you have is knowing that I can only be in the first and fourth for sine would look like, and I don't even have it here, like this. This is sine right here, okay? So those are my boundaries for sine. cannot go into the second and the fourth. Okay? And I will have those up on the board, not for the quiz day, but I'll have these posted up here. So knowing that I can only be in the first and the fourth quadrant for sine, because we had to restrict our domain, we had to dissect the graph so that we can study these trig functions appropriately as an inverse, so that it would both pass the vertical and the horizontal line test. Okay, so now let's look at cosine. Okay, cosine, same thing. What I've done is, well, I haven't, but you know, we've dissected the cosine function, just chopped it off a bit. This is the parent function. If you remember, cosine starting at 1, dips down, and then it comes back up again, but we've only dissected just half of it. We rotated it, flip-flopped the x's and y's, and so now we have this function. Now with that, we go from pi to negative pi, or pi to 0 pi is what we have. Okay, so it looks like this. This is 0 pi out here, and this is pi over here. So cosine, oh, and one thing I didn't talk about for sine is the quadrantal angles in the first and in the fourth, which would be the pi over 2 and the negative pi over 2. The 90 and the negative 90, those are inclusive. Those would be like closed circles. Okay, so same thing here. And this is just in the first and the second quadrants. And what's nice about cosine is that we don't have that negative stuff going on. Okay, we don't have to worry about the negative because we're only in the first and the second quadrants. All right, so here I'm only in first and second. Okay? All right, so now let's look at a problem using cosine. So let's say down here that cosine theta is -1/2. I'm looking for theta. I'm looking for the angle measurement. Now I'm going to use a term called arc cosine of -1/2 is going to give me theta. What the heck is arc cosine? It's the exact same thing as inverse cosine. Exact same thing. So inverse cosine is the same thing as arc cosine, but with 2 C's. Okay, same thing. And it just kind of depends upon the flavor of the author in the textbook, worksheet, whatever, on how they want to represent it, but it means the exact same thing. Okay, so arc cosine, arc sine, arc tangent, any of those, same thing as inverse. Okay, and you'll see it pretty equally either way. All right, so now I go and I look for cosine at -1/2. All right, where do we see cosine at -1/2? I see a negative cosine of -1/2 in the second quadrant, and I see a cosine of -1/2 in the third quadrant. Can I have the third quadrant? Nope, I can only have the second quadrant. So therefore, theta is 120 degrees, which is the same thing as 2 pi over 3. And then, in other words, inverse cosine of -1/2 located in second and third, but can only pull values out of first and second. So has to be second quadrant. All because that we had to dissect our trig functions. We had to dissect sine, we had to dissect cosine, And by dissecting that and then flip-flopping our x and y's, we get a new set of restrictions. We get a new domain, values that we can pull from, which limits sine to only be the first and fourth, cosine to only being the first and second. Okay, questions on that so far? Okay, now seriously, the hardest part's been done. Okay, the rest of this tangent that we're going to look at here, in fact, we're going to finish most of these notes today. Tangent is almost identical to sine in the fact that if you look at, we're again looking at pi over 2 and negative pi over 2. So tangent also is in the first and fourth. Tangent is also in the first and fourth. Now let's actually put this into practice, because what you're going to see at the bottom half of the back side of these notes, this is how you're going to be quizzed. Okay, these are the questions that we're going to be asking. So have your unit circle handy, and let's start with this. Okay, so we want the inverse sine. So I know I'm going to look for an angle. So my angle is going to be in radians and degrees. Where is sine 1 on my unit circle? And remember, it's cosine and then sine. It's alphabetical. All right, so where is sine 1? Only one place. At 90 degrees, which is pi over 2, which is 90 degrees. That one's pretty straightforward. Okay, now we're going to do the same thing with cosine. Where is cosine 1? And I think that's only one place as well. At 0 pi and at 0 degrees. Wouldn't it be what?
Is it 0 pi because you can't go all the way around?
Because I can't go all the way around. Yep. Because if I went all the way around to 2 pi, I would have crossed into the, what am I looking for, cosine? The third and fourth quadrants. I can't do that. So I just stay at 0 pi, 0 degrees.
Are you going to even use the third quadrant?
Second or, yeah, no, third is never used.
Okay.
Yep. Okay, where's tangent 1? 2 places. Tangent's 1 at any of the 45s, but the positive 1 is in the first and the third. I can't use the third, so tangent here is pi over 4 and 45, equivalent to 45 degrees.
So this is how we're going to be playing?
Correct. I mean, it does get just a smidge more tricky, but it's you can handle it. Okay, now let's look here. Second column. Thank you very much. I couldn't pull that word down. Okay, look for sine. Where is sine? Negative 1/2. It's kind of like, you know, like I spy kind of a thing. Okay, it's at negative 1/2 for sine is in the fourth and in the third. But I can't do the third, so I go to the fourth. It's here at 330 or 11 pi over 6. Can't have that. So the coordinating angle to 330 is 30 degrees. So this becomes negative pi over 6, which is the same thing as negative 30 degrees. Okay, where's cosine? Negative square root of 3 over 2. At 150, and is that legitimate? Can I be in the second quadrant?
Yes.
I can. So that is 5 pi over 6, which is 150 degrees. And where is tangent negative square root of 3. Got to have those tangents filled in.
Negative 60 degrees.
So it'd be in the fourth quadrant. And it would be down here. And it is coordinating with the negative 60, which is also negative pi over 3, which is negative 60 degrees. Perfect. Okay, questions on that? Hallie?
On the first one in this column, when we're looking for sine negative 1/2, that's in the third and the fourth quadrant, but we can't use the third one. So in the fourth one, and it's on, I'm just confused in how we got it to correlate with the 30 degrees.
Okay. If you take what originally is 330, what's 360 minus 330? 30. That's how you can also find your angle measurement, by subtracting it from 360. And that's finding your reference angle. And so in here, I had them both green. All my 30-degree reference angles were in green. And so that's how else you can know that. And if you just kind of look at it, this angle created from this ray to the x-axis, that is a 30-degree angle. Then I go down to 45, then I go down to 60. Okay? All right, so now we've got a little bit trickier situation, not too bad, but I have two different measurements here, two trig functions going on here. And this is where I'm saying you need to know that you know that you know that you have angle measurements versus a side ratio, okay? The inverse represents I'm looking for an angle. Just the sine, cosine, tangent means I want my trig ratio, okay? So always, just like order of operations say, you want to work inside the parentheses out. Work inside out, okay? So always start on the inside. So I'm going to start with inverse tangent of 1. So I start with where is tangent 1? Where is tangent 1? At 45 degrees. Okay, so tangent 1 is at 45. And in the fourth quadrant that I could also be, I have a negative 1. So I know that this is the only one I'm looking for. All right, so tangent 1, I'm going to just cross that off. That's 45 degrees. So now I have a new problem. The new problem now is what is sine of 45 degrees? Okay, so I go to 45 degrees, and the sine value is 1 over square root of 2. Okay, the one right below that. I want cosine. It's not inverse, it's just cosine of 7 pi over 4. So I go to 7 pi over 4. Here it is. What's cosine of 7 pi over 4? I'm not looking for inverse, so I can be